his target,
Yeah.
right? And so you had this magnet, and that magnet would you would adjust the field on the magnet, and it would switch the particle to go down the various lines. And you know what happens when you have a charged particle and it bends? Do you know what happens? Radiation.
Synchrotron
Yeah.
radiation.
Yeah, because you're accelerating it, and so radiation comes off. So off of that switching magnet, they had some nasty. So we used to put cockroaches there. we used to do some really crazy shit, you know. And now and then we would take, because back then you had to wear a dosimeter badge, one of the big ugly brown ones.
The green one. Yeah, I had a green one.
I had a brown one, and it was a big ugly one, right? And so if you want to fuck somebody up, you would take his badge and put it at the switching. So we did.
Now you're being a bastard.
But you were doing him a favor.
Yeah, true.
So Dave, did you go to McMaster in the 50s? Because the last linear accelerator was built in the 50s, and apart from SLAC, they stopped making them after cyclotrons.
No, the one the one that they had at Atomic Energy at Chalk River, and I don't know if you remember seeing this, Dave. They had a Van de Graaff linear accelerator.
McMaster had a Van de Graaff. Yeah,
right.
The same thing. A big giant a tank, right? Had a big giant tank. And in that, it had the Van de Graaff that was generating the charge, right? And that's what did the linear.
Yeah, there was a big charge belt, and at the one at Atomic Energy, the voltage differential was like 13 million volts, and they actually had to use a gas, SF6, in order to insulate the inside, so there was no arcing going on.
And if that shit escaped out, you're in trouble. Oh, you're bringing me back memories.
Yeah, they had oxygen sensors, like all around that part of the facility. Yeah.
I spent lots as an undergrad. I was one of the few undergrads that worked as a student operator, operating the accelerator. So I used to do midnight shifts. And I remember going in there and tweaking the dials because all current, right? Anyway, we're
breaker.
Yeah.
But before you break, I wanted to mention to talk to Kevin's point about frequent measurements. I used to be mightily impressed by these measurements until I realized any time they have a super precise measurement, they're just measuring frequency and comparing it to an atomic clock. And so that's the secret of high precision measurements. Turn it into a frequency measurement and compare it to an atomic clock. And that's how you get high precision, as far as I know. Because the atomic clocks are the only high precision references we have. Anything else is basically analog voltage kind of measurements, which aren't that precise. So that's the way forward. Turn all your measurements into frequencies and compare them to a GPS stabilized atomic clock. And
next month's conversation, Eric.
All right. Yeah, I was being the good cop. The bad cop had to show up. So anyway, interesting conversation though. So that's why I let it go on a little bit. But for somebody who says he doesn't like the rag chew, OOI certainly can do it when he wants to. So all good. Well, good evening, everyone. For those that I haven't said good evening to, welcome to the February 7th, 2024 AF mixer of the SOAREX group. So good crowd here tonight. Well, anyway, welcome to everyone. I'll start off by reading out the disclaimer. Please note that all of our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. Okay, and also please note that we have discovered if you turn your performance settings down in the Jitsi menu, you might make the overall experience better for yourself and everyone. It seems to put a little less strain on the free Jitsi servers that we're using. So, and cameras off also help too. So you can consider that. You don't have to turn all of your cameras off, but it's a thought. All right. So, if anyone has anything else that they'd like to add to tonight's, agenda of sorts, please raise your hand. Otherwise, we have Charlie, who is going to be talking to us about computer radio interfaces and some notes on, designs and considerations that you want to take into account. I've got a brief discussion of a buildathon that went on over the last couple of weeks. It was a QRP-Me live buildathon of the Tuna Tin transceiver. So I've got a few things to mention to you about that. And that's really about it as far as the formal informal part. So anyway, all right, we'll get right into it, I suppose. Charlie, are you ready for action?
Absolutely. Let me just share a screen here. By the way, Dave, when I was driving through Chalk River a few days ago, I saw a cockroach there about the size of a cat. So that may be something to do with your experiments from a few years back. Let's see. I'm going to share an entire screen, and I'm going to share this one. And then I will put this in projection mode with a bit of luck. And you should be able to see my chart. Does that
Yep, looks good.
makes sense? Okay, great. So where this started out, it's a bit of a rabbit hole, which all of us go down. About five years or so ago, I wanted to start playing with APRS, and I also wanted to start playing with FT8. And the only HF radio I had at the time was one of Farhan's microBitX devices. And it didn't really have a greatly defined, it certainly didn't have a built-in cat controller or anything like that. So I started poking around, gee, what should I do in terms of an interface between my computer and my two radios for those two different applications. The first answer I got, of course, when I asked was, go buy a Signal Link. And then I looked and saw, Signal Link, $200, and said, yeah, I don't think that's where I want to go, particularly when I think I could build something myself for, less than a tenth of that. So I started down the path of, okay, what does this interface need to be, and what does it need to do? I kind of set up my objectives. I want to get to a very low cost solution for experimenting with APRS or Packet for under $20. I want to be able to do something that I could do with my HF radio, but honestly, these days most modern HF radios, they come with a built-in computer interface anyway, and so you really just need to plug in the USB and you're good to go. But not so with the microBitX, and so I use the interface for that. I wanted something fairly small and portable, something on the order of maybe the size of a deck of cards or a bit smaller. And I didn't really want to depend on Microsoft Windows. I'm, becoming more and more disillusioned with Windows, and I think by the end of this year, I probably won't have any Windows machines at all. On the other hand, there shouldn't be a need to dump Windows. If you really want to use it, then you should be able to use it with whatever the solution is. And because I want to do things portable, I don't really want to be carrying around something as big as a laptop. I always have my cell phone in my pocket, even if I'm somewhere where I'm off grid. So if I need a keyboard, mouse, and screen, I'd love to be able to use my cell phone for that. Although, if there's a laptop around to use, fine, we should be able to use that too. And, again, it's not really necessary to be a Windows laptop. A Linux one or a Mac or something like that should work as well. So when I dug into it a little bit deeper, I started looking at, well, what are the fundamental requirements of this? I got my computer, I got my radio. Between the two, I need audio to flow in both directions, obviously. I need some method to key the transmitter. And some of the things I was thinking about playing with need some kind of an indication of an incoming RF signal. So that's called, COS or COR, carrier on switch or carrier on relay, I think. And something like All-Star requires that. And then we need to do some DC blocking or level shifting because the computer voltages and the radio voltages probably are not the same. And we want to keep the radio RF out of the computer. So the bits and pieces. First, let's talk about the CAC control. Some way to key that transmitter or get a signal from the computer, from the radio into the computer. And on the computer side of things, my favorite solution these days is the Raspberry Pi. And a Raspberry Pi Zero will run you, about $21 these days, or perhaps less. That's your computer, and that's your interfaces to the outside world because it has several GPIO pins. They're 3.3 volt, so we're going to need to do some level shifting and things. But the nice thing about the Pi is that it can just drive to the radio. Laptops and other solutions generally don't have any kind of a GPIO setup. So we'll need to do something different for those. And for those, when I was poking around, I found this UART device. It's basically not quite an RS-232 interface. It's RS-232 format, but it's TTL. This particular one, I found at Universal Solder. And what I like about this one is that it has this DTR pin brought out, and a lot of the software will actually use DTR as a PTT function. So for my laptop, I just plug in this device, which cost me just under $5, and I can use DTR and ground, and I get my push-to-talk signal, which I can use to drive the radio. In terms of audio, usually if you're running a laptop or something similar, you can use the sound card that's built into the computer. Having said that, it's pretty easy to get bleeps and bloops that the computer likes to make coming out that sound card. So it generally is helpful to use an external sound card. Certainly with the Raspberry Pi, you need an external sound card. It does not have a built-in one. And so I started looking at what do you really need for that? It turns out that the bar is pretty low if you've got a 44.1K sample rate sound card, which is almost anything that you can find out there. It will happily do the 300 baud and 1200 baud stuff. If you want to go up to 9600 baud on UHF, then you benefit from a sample rate of 48K. It will probably work with the 44.1, but 48 will give you a little bit more room. And honestly, to experiment with any service you can think of, there's lots of low-cost cards out there available now that run up to like 192 kilohertz. So sound cards are out there. So what do they cost? Well, Here's one I found for $2.78. Um, and it works quite fine. I bought a couple of them, played with it. They do a great job. So between that and this little UART card, I can control my radio from my laptop. If I'm using the Raspberry Pi, I need the sound card, and I don't need this UART device. A word about these super low cost sound cards. They are often, when you open them up inside, you'll see that um, they're using a technology called chip on board. I don't know if everyone's familiar with that or not, but essentially, instead of putting the chip, the sound card chip, inside a package and then soldering the package onto the board, they actually take the silicon chip, glue it down on the board. They use, they bond it out to pads on the circuit board, and then put a glob of sealant over the top of it to theoretically hermetically seal it. I kind of worried about this technology when I first heard about it more than 20 years ago. It was being used for super cheap things like musical Christmas cards and those sorts of things. So I didn't feel it would have a lot of longevity, but there are a lot of devices out there with this that seem to be working just fine. There doesn't seem to be a very high failure rate, I guess, is what I'm trying to say. And to be honest, unless you're doing a lot of stuff out in the woods with this, if you're a pretty controlled environment in your shack. So I think this $2 card or $3 card is probably all you need. However, having said that, if you want to drop a couple more bucks, you can get one that's actually in a proper package. This one was $14 at Amazon. What I like about this particular one is that because it's in a package where all of the CM108 pins are brought out, you can take advantage of the GPIO pins that are built into that sound card chip. It has some GPIO capability. So now you can take your laptop, plug this thing in, and attach a wire to this particular pin. And most of the software that's out there will use this pin, this signal for push to talk. So that's an advantage of these. It's a bit of a bear to solder the wire on there. You need to be quite cautious, but when you do, you've now got a valid PTT signal for a large chunk of the software that's being used for digital modes or for WinLink type services and so on. By the way, also true with this one, this is sort of the recommended device for things like All-Star. If you need a COS, the pin on the opposite side will serve. It's another GPIO, and since it can be an input as well as an output, as the name suggests, you can put the carrier detection signal into that pin. Again, caution, these are 3.3 volt things, and we know that your radio is probably 12 or more volts. So on the radio side, we're still not talking too much about this box in the middle. On the radio side, the interface tends to be pretty brand specific, and sometimes it's even model specific. So if you choose to build one of these things, I guess your homework assignment is to figure out what the connections are for your radio. I do have a couple examples here. The Kenwoods, the Baofangs, and Anytones, they all use this type of connection with this double plug that's got a 3.5 mil and a 2.5 mil together. These connections are, the microphone connections tend to be on the fat plug, which is surprising. I would have thought it would be the other way around. You connect the two ring circuits together here in order to do a push to talk. So speaker gets connected from the tip here, no connection to the ring, and the sleeve is the ground on the 2.5 side. On the 3.5 side, this is a positive voltage that is used by some devices for biasing the microphone. The ring is one side of the mic, and the sleeve is the mic return. And again, tying those two together is what causes this thing to transmit. Here's a picture that I found for the ID51. The ICOM ID51 is another popular radio. It's a little bit different, but as you can see, again, the push to talk basically grounds the mic ground to this external ground pin here. So those are a couple examples. Don't know what radio you would like to use. Yours is probably different. But if it's one of these, this is how you'd connect it. Just a note, guys, I'm looking at the slides here. I'm not seeing the screen of everyone. So if you need to get my attention, a question comes up or something, please just interrupt.
Okay. Everything's looking good so far, Trev.
Okay, thanks, Eric. Okay, so given that we got a bunch of analog folks in the room, I think this box in the middle is the part that everybody's most interested in. There are still a few functions that we need to do in that box in the middle that we haven't talked about. There's the protection between the radio and the computer. There's an adaptation of impedances possibly, and probably some level shifting, almost guaranteed. Certainly level shifting and isolation for the control signals, and then figure out some method of reducing the conducted RFI from the radio to the computer, which can tend to make the computer very unhappy. So here's a schematic of the circuit that I use most often. And probably the first thing people will note here is that there are no transformers in this circuit. And that is absolutely true. The requirement to have transformers in this interface is very old school, let's say. Back in the day when you had a big giant radio in the corner, maybe even a tube one that had its own power supply that ran off to your fuse panel, and you had a desktop computer with its own big power supply that ran off to another wall plug somewhere else. The distance between those two grounds was quite large, and it was quite easy to get voltages developed between the grounds. These days, probably your radio and your computer are both battery powered. And they're probably sitting only a couple of feet apart. So you're in much better shape to just tie those grounds together and not attempt to isolate them and keep them apart. The objective is that you don't want signals between those grounds. So if your radio is drawing massive amounts of current from a wall socket, or your computer is, when you key the mic, you're going to get a current surge, which will be a noise spike between the two, which can mess things up. If they're both battery powered and they're both close together and those grounds are tied very tightly coupled together, then you won't have that problem. So before I talk about it a bit more, I do have a circuit with transformers in it and opto-isolators, because you'll need to isolate the control signals if you're going to attempt to keep those grounds separate. I've built both of these. They both work just fine. The transformer one here, it's bigger, bulkier, more expensive, more things to break and go wrong. I am very keen on this particular circuit. What I'm doing is the GPIO coming from from any of the sources I talked about earlier. Basically, it's a 3.3 volt signal. It comes in and fires up this this FET, which pulls the drain of the FET down to ground. I'm using a 2N7000 series. It gives me, I don't know, five or 7 ohms of resistance there. And then I use that to actually pull the PTT pin on the radio, or connect those two grounds together, depending on which radio interface I'm trying to talk to. This 22K is what's used for the ID51. You change that down to about a 1K or so if you're going to use a Baofeng or a Kenwood. And for my microBitX, I take it out altogether and I use the PTT pin to key the mic on the actual radio. The other functions that are in here, we've got some 50 ohm resistors here. Basically, the speaker from the radio is, older radios tended to be 8 ohm impedance they were looking for, but newer ones tend to be on the order of 30 or 40 ohms. So what this circuit does is it guarantees a 50 ohm minimum. And probably, with a 50 ohm here, an equivalent 50 ohm from the microphone over here, this will certainly be less than 50 ohms. Exactly what it will be, I'm not completely sure. Depends on your computer and your sound card and whatnot. But you'll have at least 50, and that's enough to keep the radio happy without damaging it by attempting to draw too much current. And the 250 ohm resistors here create a bit of a voltage divider for us. So we knock down the output of the radio, which tends to be fairly loud. We knock it down by 3 dB right off the top here. Then capacitively couple it with a good quality capacitor. You can use a good ceramic here. I use a poly cap. I find they have a little bit of a better sense of humor, but either of those will work as long as you're not into doing something silly like electrolytics. You'll be in good shape. And then the other side of that cap just gets put right into the computer microphone. The speaker out from the computer. Some of the programs use the left channel. Some programs use the right channel. So I've basically bridged the two channels and through a 50 ohm resistor so that each channel sees at least 50 ohms, possibly 75 with these two in parallel from this channel, same from the other way. This one ends up in parallel with this. Again, same kind of cap that we're talking about that I mentioned up above, and that gets driven into the radio's microphone. And these other components here are for, as I mentioned earlier, this is for the push to talk. If you're doing one of the services that requires COS, then you basically have the same configuration that you had for PTT, but reversed. So the COS output from the radio drives this FET, which in turn grounds that GPIO pin on the computer. Most of the interfaces I've built don't have this. The only service I've really hit on so far that requires that COS signal is All-Star, but I certainly haven't experimented with all the digital services, and I'm sure there are others out there that would require that signal. This circuit can end up being quite compact. So here's a little circuit board I made for it, just because I was building a lot of these and I got tired of soldering them together all the time with on perf board. I made up a little circuit board for it. This is like 1 inch by 1 inch. It nicely fits in an old pill bottle. It got a few of those around. I'm sure most people do. And at some point we can talk about the soldering method for this, because this one I did with a heat gun, a Canadian Tire heat gun, not a specialized reflow solder station. Don't know if I'd want to do that with the active devices, but certainly for the passives, it works quite well. You can see it made a pretty clean construction for those 50 ohm resistors that are all over the place. But that's the whole circuit. I mean, it's what do we got? 3, 6, 9, 9 resistors, 7 of which are 50 ohm, 2 of them are 10 Ks, 2 caps, and that FET. Any questions so far on this? Or?
I can wait till the end.
Okay, I'm getting close to the end. One of the considerations that I came across when building this interface was, if I'm doing FM, how do I know that I've got the deviation correct? This is another one of those fun measuring questions. So, how do we set the deviation and not cause distortion and damage us and bother everyone else in the neighborhood? The good news is that most of the modern radios are really, really hard to overdrive without obvious distortion. So you basically listen, and if you can hear the distortion, turn it down. You can use a deviation meter, of course. Those are available, or you can do it with a spectrum analyzer. If you've got a receiver that's capable of receiving on CW on that frequency, you can use something called the Bessel zero method. Basically, you key the transmitter with no modulation, tuned to the carrier, and then start listening for the beat tone when you can hear it. Then add, say, a 5 kilohertz. Add a 2 kilohertz modulation, or 2079 hertz if you want to be really specific about it. Raise the input volume on the transmitter from that's the input volume from 0, moving it up, and you'll hear the carrier start getting quieter. And if you keep turning it up, eventually the carrier will hit a null. And when you hit that null, you're pretty much at the 5 kilohertz deviation point. So then you're done. And the other approach that someone told me about, which is considerably less scientific but works quite well nonetheless, turn up the transmit audio until turning it up more doesn't make any difference in what you're hearing on the other radio that you're listening to in the room. Start turning the volume down until you notice that it's actually quieter, and then you'll be at about 4 kilohertz deviation. So that's it's arguable whether or not it's necessary to set the deviation, but simply because it's hard to overdrive the modern radios. But to be strictly coloring inside the lines, it's a worthwhile thing to do to make sure that you're not bothering anyone else. I think at this point I'm going to pause and see if there are any questions. Peter, you had one, I think.
I was just going to say, I have an original Pi. Can it be used, or is it pretty much gone to the wayside now?
You know, this particular function, depending on what digital services you're trying to run with it, it doesn't take a whole lot of MIPS to do that. So for APRS, for instance, you tend to use the program Direwolf is my favorite for using for that. This will run Direwolf forever. I've got a Pi Zero, which is probably the lowest powered Pi you can buy, even compared to the original ones. And I've got this running on mountaintops for long periods of time with no issues. So if you're into something that you want to have a bit of a display with, there's programs like Zaster, which give you a graphical display of where you are on the map and so on. That takes a bit more poop, and I think you'd want maybe a Pi 3B or up to do that sort of thing. FL Digi I've run on a 0. FT8 I've run on a, I don't think I've tried it on a 0, but I had moved to a 2W from a 0W, and when I started playing with FT8, and it runs quite happily there. The original Pi Zero, though, will run PAT. PAT is a WinLink application. So with PAT and Direwolf, for instance, I can run WinLink with this thing, whether I'm doing it on HF or on VHF with that low-end computer.
Okay, thank you. And one other one I have is going back to the sound cards. The second one you showed there, it was easy to access the PTT or the COS pins. But on the 3D sound card with that, I guess that little protective goop that's on top of it, could you still access those pins on that particular sound card?
You can't, because those pins are typically not used on the sound card. Like this it's a general purpose audio chip that was produced. Mm-hmm. And it was used in VoIP telephones. It was used in computer sound cards. It was used in a number of things. So when they just made the El Cheapo version of it with the sound card, they didn't bond out those pins.
Okay, thank you, Charles.
Charlie, I have a question for you. Can you just define COS, that term?
Yeah, it's carrier on switch. Basically what it is when there's a carrier present, the radio detects a carrier, it will toggle a line. It's not common on all radios. They're ones that were intended for use in repeaters, for instance, often have it available. Some of the Chinese radios have it. The old Motorola's, the GM300s had it. So it's not, certainly not all radios have that capability.
Okay. All right. Thank you.
It's sometimes called COR as well, which would be carrier on relay. And I think some folks who've been around for a while would tell me that COS is like it goes positive and COR goes negative or something like that typically, but I don't know. The radio I've been using for this is one of the old Motorola's, and its COS line basically is programmable to do either. So.
Okay. I saw a hand go up. I believe that was Howard.
No, sorry, I was turning off the chat. I hit that by mistake.
Oh, okay. All right. False alarm. Okay. Any other questions from the group from Charlie? Oh, Peter again.
Charlie, just to clarify, when you're talking about the use of a transformers and not, the only time you may want to use the transformers is if your computer and your radio are plugged into the 120 volts. Otherwise, if you're just battery operated, then you can scrap the transformer circuit.
Uh, that's definitely the case, and you can often scrap it as well if you're plugged into 120 volts. It really is how long is that ground connection between the two devices?
Mm.
Um, so if one or the other or both are battery powered, then the ground between them is really going through that sound card anyway.
Okay.
Um,
Oops.
Lots of questions. Dave, I think, is
Dave's
next up.
next.
Charlie is going to comment about the transformers. That's for Peter's for ground isolation, for especially if you got RFI. For my computer interface, I had tons of RFI. I not with FM, not with a 2 meter radio, but with my HF radio, I was plagued with a ton of RFI, and it would cause, as Charlie said, it would cause havoc on my computer. And so I had to isolate all the grounds, so the radio ground does not touch my computer ground. And I use transformers and I use opto isolators just to make sure the grounds didn't touch. And that way I couldn't get RFI going from the radio to the computer.
And Dave, did you try ferrite on the leads between the two?
Yeah, I tried all kinds of stuff. And it's just because I run shitty antennas. That's, you know.
Yeah, no, fair enough. If you if your antenna is not a perfect match, you'll get RF coming back into the shack, and it's very easy to get that
Yeah,
into the circuit.
I've
And in
got,
fact, I've even done that with the VHF FM stuff. If I've got a badly matched antenna sitting physically close to the computer, it's going to cause problems too.
I've got probably, I invested so much getting those clamp on chokes, you get from DX Engineering. I've got probably about at least 12, 15 of those clamped onto my line, coming
Mhm.
into the house, and I still have RFI coming in. So one of the things I'm going to have to probably do is cut the line and put an actual, like what's it called? A common mode choke, I guess, or something like that.
Yeah, common mode choke will certainly help with that, but if you get a physically larger ferrite toroid and pass the coax through it multiple times, each time you pass through, the impedance goes up by the square of the number of turns, right? So looping it through it multiple times will help a lot more.
Yeah, the problem is I've got LMR cable, which you can't
Doesn't
loop.
bend so good.
Which
Um,
there's no
uh,
way you can loop that.
and are you running an end-fed half wave or something, Dave?
No, it's actually it's a it is an NFET. It's a random wire.
Okay, random wire. Yeah.
It's
Okay.
it's a random wire, and it's got a ICOM random wire tuner.
Mhm.
And the ground on that, the counterpoise is so important, to
Yeah.
soak up that RFI.
One of the things I found with HF, the quality of the coax is less important. I guess the losses in it are considerably less at HF than they are at VHF or something. So I'll typically use RG58, and I'll take maybe 20 feet of it extra, coil it in about I don't know, a 6 to 8 inch coil, lay that on the ground and put a block of wood on top of it, and that seems to solve my conducted
Yeah, because
RFI.
the loss is like under 2 dB per 100 feet or something like that.
Yeah,
And there's no
exactly.
way you're using 100 feet. Yeah,
Exactly. Yeah.
yeah.
But yeah, certainly, the transformer-based circuit does, if you got to try and keep those grounds apart, then yes, the transformer-based circuit's the way to go. But I have one. I say that I built. I have the schematic for it. It's sitting in the corner. I never use it. I always use the little capacitive coupled ones. Um, since I made this little circuit, I made up about a dozen of them, and I've got them scattered all over the place, working happily. maybe I'm just being lucky too. Any other questions on this stuff?
I don't see any hands up. So going once, going twice. Do you still have more to show us, Charlie?
I actually really don't. Let me. I can maybe just show one last slide here. I was asked if instead of trying to do that PCB version, if there's a through-hole version, and yeah, absolutely, pretty much the same physical size. That's the through-hole one here, and you can see the pill bottle that it's typically sitting in. This one's for use with my Baofeng. But that's it. I've
That's a
got,
skinny pill bottle, right? That's like an 8 gram.
yeah, it's the this kind of standard size, right? The little ones.
Yeah. That's
Yeah, sure.
impressive.
Show the pharmacist a pill bottle. Yeah.
Well, I had to, obviously, bring that up. But I mean, yeah, that's impressive. I thought it was going to be one of the really chunky ones, but no, that's nice and compact.
Yeah, it's quite small. Like I say, the circuit board even it's a little bit wider than that. The circuit board I think is just under an inch on a side. So, okay, I think that's probably enough of this. If there aren't any other questions, then I'll say thank you.
I guess is that like how general purpose use is that the circuit itself, or is it going pretty much from most like could you characterize how like many radios that would work with
The trick is the most of the radios key PTT in a different fashion. Some tie the mic ground to the speaker ground. Some have a separate pin for it. So I've tried to make that board as generic as possible. The interface circuit with the resistors and capacitors never changes. There's one value of resistor that goes between the two grounds that changes between a couple of different brands. And as I mentioned, you remove the resistor completely if you want to use it with a radio that just does PTT, right? So again, I'll share the schematic one last time here. So this resistor here, the push to talk comes from the GPIO pin coming out of the computer, and it turns on this FET, and the FET either pulls the mic ground through a 22K resistor to the speaker ground, or it pulls I guess I should call it the microphone return through this 22K resistor to ground, or replace the 22K with a 1K if it's a Baofeng, or if it's a radio that has a separate push to talk line, then just take that resistor out completely and connect your push to talk line over here. So it was really, the intent was to use this circuit with this circuit board with a number of different radios, and so far I haven't hit one that I'd have to do anything different with. It's pretty generic.
Okay. Very good. All right. Well, thank you very much, Charlie. I think that held everybody's attention quite nicely there for about 3/4 of an hour. So, right. Well, we will move on to my brief show and tell here, which I will have to share a screen as well. So let me see if I can do that. So there you go. Kind of small, I guess. I don't think we're even seeing, well, I guess I have it zoomed in, but hopefully you can see that. Over the past couple weeks or so, there were 3 evenings that Rex W1REX from Maine had a something a little different. He's done many buildathons, obviously, in the past at events and online buildathons, but they've always been single day, single day and 2 hours, 3 hours that they're crammed into. So he did something a little bit different this time. Wasn't advertised very far and wide, but if you were subscribed to the QRP groups.io or kept tabs on his website, would have been announced there. So I didn't find out about it till probably the week it was the first session happened. But anyway, so it's over 3 nights. And that allowed for a little bit more civilized build. So essentially, anyone that was interested for $30 got a kit that had 4 components in it. The transceiver there, which essentially is a very slightly iterated version of a 2016 tuna tin transceiver that was made for the 40th anniversary, as you can see there labeled, of Doug DeMa's original tuna tin from 76, I suppose it was. But anyway, so like I said, slightly modified from that, but that was not done until the second night. The first night was basically a key, a RF probe, and not pictured here, a dummy load. So the 3, accessories were discussed and put together almost for practice on the first night, first session, I should say. And there was also, talk about, the why you do QRP circuit, the actual tuna tin circuit, going over the various sections of it, and how everything operated. And then the second session was the actual build of the tuna tin 2. So some people had already done it or part of it, but there was opportunity to ask questions throughout that. So, but that was it. It was really just putting the components on the board. The last night was essentially making sure that everybody's kit was up and running, and then using the various bits and bobs that you had made on the first night to test it. So testing DC voltages throughout the circuit with a schematic up on the whiteboard, probing for RF voltages throughout with the probe that was built, and a voltmeter. And the dummy loads for transmitting, the key for keying it, and well, that was it essentially. So any debugging that had to be done was done on that third night, and I think everybody's pretty satisfied. I would say there were about 25-30 participants for the buildathon. It's something that he, I think, is going to be doing in the future. That was his aim, was as a test run for it. So anyway, that was basically the long and short of it. That actually is a picture of mine, and not quite complete. Didn't quite get to putting everything on it yet, but all of the sessions were recorded on his YouTube channel and available immediately afterwards for those that couldn't participate during the sessions. And it was also simulcast, I guess you could say, to use an old term, on something called RF Summit, which is I guess a POTA type of QRP channel that fellow runs. I forget his call, but NJ7 something. Anyway, so there you go. That was what I guess you could say semi-participated in over the last couple weeks. So pretty successful. Rex is getting a little bit more polished at doing the online things. He's got somebody who assists throughout the build and kind of smooths over the rough edges, and yeah, it went well. So anyway, there'll probably be more to come. So if you keep an eye on the QRP.me site, you'll undoubtedly see more of those. Nothing scheduled at this point, as far as I know, but I think he was pretty happy with the results. So, Peter, yep.
You mentioned at the top that there was 4 components. I count at least 25. So what were you referring to when you said you only had 4 components?
Four major bits in the kit. So the transceiver, the dummy load, the probe, and the keyer. So the little simple keyer, the red thing down at the bottom. So four kits, with kits within a kit, I guess we'll call it that. So
okay. And your probe is starting to look pretty good from where I'm sitting right now. Oops, was that my outside voice?
Well, like I said, it's you gotta baby steps. Charlie.
I was just going to say, Peter wants to borrow your probe for a couple of weeks.
Yeah. I'll mail it to you. Be there a couple nights. All right. So anyway, just wanted to share that with you guys, and maybe once I get all the components soldered onto it, after I finish the common emitter amplifier circuit, I will share with you my results. So there you go. Maybe even get it on the air for next week's Carex QSO. You never know. So that's a possibility. It's a 40 meter as is. So. All right, so that was that. I don't think anyone had anything else that they had brought up as far as show and tells for this evening. So let's see, we're about 8:30. So perhaps we'll get right into the round table and see what everybody is doing. So let me stop the screen here, get back into the main room, and we'll go around around my screen, I guess we'll say, and I'll do it in the standard fashion clockwise. That actually means you, Charlie. So other than working on the interfaces, have you had time for anything else?
I've got a couple of other projects on the go. One is, and the interfaces are, of course, part of it. One is an all-star node for the club in Pembroke. We've got that kind of in up and running, sort of, at this point in time. It has a couple of bugs in it we're still working through, but it's coming along. I've also taken this this interface that I described this evening, and I put it together with some software on Raspberry Pi to create a WinLink emergency VHF kit, if you like. That again, it's about the size of a deck of cards that you can throw in the glove compartment of the vehicle, use with your cell phone and an HT if you've got one handy, and basically send emergency communication stuff for people, if you get called out to do so. So put it together into a nice little package. It's using the PAT WinLink interface, which runs on Linux, but also runs on Windows or anything else. And it has the standard emergency communications forms and so on. So it's a nice little package in the Raspberry Pi that is quite useful to have. And I've got working with the club up here, I think, to start getting a few more people with these units available, because they actually still have a packet network in this area that's used quite a bit.
Okay.
That's probably it for me.
Yeah. Okay, very good. Thanks, Charlie. Al, how are things looking on your always busy bench?
Well, it's been a busy month, actually. I can't say I've done too much, but I did find a a couple of weekends to get away from the hustle and the bustle and dive into a couple of builds just to, well, not too challenging, but to relax, I say. One of the ones I built was I ordered a Z tuner kit from the GQRP group out of London, and it was quite an interesting kit. It comes in an 8.5 11 box, only about 3/4 inch thick, and that includes the case. And what they've done is the PC board and the case are all out of PC board material. You snap the panels off, solder them together, and you end up with a case. So let me see if I can actually show this on the camera. I'm working. Okay, which way is up here? Okay, I'll show it from there. There's the. Hi, golly, this is all backwards, so I'm going left when it should go right. The front end of it is a Z tuner with a bridge and an LED on the front of it, which works quite well. Inside is a main toroidal transformer. The larger resistors are part of the bridge. It's tuned with polyvaricons. The back side of it is full featured output, so you've got balanced high and low impedance, and also unbalanced for coax. The whole package is only 4x4 by 2 inches. Went together really well. One of the interesting things, I don't know whether I can show it in there, but you can actually see the, is it going to focus for me? There it goes. It's all through-hole components onto Manhattan style pads. So there's it's quite easy to do. Anybody looking for an easy project to do, I think it only took me one evening to put this in together. It does work rather well. I quite enjoyed it. Now, granted, you can get onto AliExpress and buy a Z tuner for QRP for like $30, and then this is probably twice the value. But I think I got twice the value and fun out of this, and also started thinking about doing more Manhattan style and more using of printed circuit boards for cases. So altogether, I was pretty happy with this thing. So like I say, I wasn't designing anything. I was just following the instructions. It worked very well. You could probably scale this up. It's only intended for QRP, so 5 to 10 watts. But you could scale it up quite easily. So yeah, highly recommended. Anyhow, that's about all I've been up to this month. That was my stress reliever last weekend. Got away from all the things I had to do. I played hooky and I heated up the soldering iron and had a little bit of fun for the weekend. So that's pretty much it, Eric. Like I say, maybe I'll have something next week, but you know, the life is too busy right now. I need to retire.
There
Yeah.
you go.
Back to you, Eric.
Great, thanks. And that was ARRL or RSGB
No, that was GQRP.
or GQRP, right?
Yeah.
Okay. Yeah.
The guys that also make the Sprat magazine.
Right. Yep.
Yeah.
Okay.
Anyhow.
All right. Nice. Okay. Well, thanks very much, Al. Hopefully that tickled the appropriate things for you for the busyness and got you a little bit back to doing what you should be doing.
Therapeutic.
Yes, exactly. That's good. All right. So we'll move on to Dave. What are you up to?
Yeah, lots. Finally got around to applying the hack to my spectrum analyzer. So now I've got my spectrum analyzer completely open. I can do all the measurements. And Peter, one of the things, once that hack is in place, you can use a directional coupler to measure impedance. So what we were doing with the trace, traces and putting those resistors in place, well, if your spectrum analyzer is open and it can measure return loss and reflection coefficient, may be possible for you to measure impedance. But anyway, so that's one thing. The other thing, I finished my Eclipse beacon. So that's my Eclipse beacon there. So that's, I'm going to be using that in the Eclipse to measure propagation. This does whisper CW, but it's got a mode that I call QRRS. And so I use something called a lock-in amplifier to detect the signal from that beacon. And it seems to be working pretty good. All my tests are positive. So, hopefully, when the eclipse come, I'll be able to, deploy this and measure propagation. One of the things I'd like to put out to the group, by the way, I've got extra of these boards if you want to build your own beacon. And it's driven by a Arduino Nano. So you could write your own software to do, whatever. It puts out one watt. But one of the things I want to put out to the group is during the eclipse, I'm looking for volunteers that maybe would want to connect this to their antenna and run it so that I could listen and detect the signal and measure propagation. So that's it.
I'm curious, Dave, at the risk of having this on our public YouTube channel, is there a sort of a clearinghouse, central repository of hacks, for analyzers, scopes, etc., that kind of thing, for opening them up, or is it just a matter of Googling it?
I came from Peter.
Yeah.
Go ask him.
I mean, obviously, it's out there, but is it relatively easy to find? I guess that's the question.
Well, I have no idea. This came from Peter. And it was tricky. Peter, if I didn't follow the instructions, it doesn't work. But you got to follow the instructions to the letter.
Okay. Fair enough. All right, Hassan, you are next on my list.
I joined early today. So no show and tell. I was building a bookshelf for my books, hidden bookshelf. So I put all my RF books in a closet behind another bookshelf. So they're on the first floor now and safely hidden away. But I did have an ask and listen thing. One of my colleagues he lives in a bit of a node near Courtright Center. So it's kind of in a valley, and he doesn't get cell coverage at his house, and it's causing a lot of problems. And I was wondering, is there a way to build a simple passive repeater for him, just to get cell coverage? Does anybody know of any ways to do that?
Hassan, what I've seen, I don't know if this works, but I've seen some antennas where I think it's supposed to be used by truck drivers and whatnot. So just literally just a bigger antenna, and you keep your phone close to the base of this antenna just to get a bit more RF coming in. I don't know if it works, but yeah.
Like a horn almost?
It wasn't a horn. It looked like a whip. But what was it like when I saw it? I can't even remember where I saw it, but I remember seeing it, and I was like, "Where do you plug it in?" And you don't plug it in. It literally you keep the phone next to the base of this antenna. So I guess it just kind of leaks the RF back out.
That's interesting.
Yeah.
And I was thinking more like the tin can thing we used to do with strings. Um, Basically have a helical on one end and then a coax coupled to that and then another helical on the other end.
Yeah. I think
And
Dave wanted to jump in there.
yeah, Dave.
You're muted, Dave.
Is this for Wi-Fi? Is it for 2 meters?
Oh, it's for a cellular.
Oh, cellular. Yeah, one of the things I did, you were up to my place in Caledon, right? I was in a
Yes.
valley, right? And I had no signals. I couldn't reach any 2 meter repeater. The only one I could actually reach was the King City repeater. And so what I did, you know what Raleigh uh, scattering is?
Remind me how it's different from other scatterings.
Yeah, it's like across like a hilltop. So
Okay.
what I did was I bought a cubicle quad, which was a directional antenna, and I aimed it, towards the park repeater, even though it was below the hill, and I aimed it, and I was able to hit, I guess, the edge of the hill and scatter over the hill, and I was able to get to the repeater. So if you could get some kind of a directional antenna and point it towards the um, cell tower, you might be able to get some Raleigh scattering.
Interesting. So that would take care of the transmit side, but on the receive end, is
Both,
that enough?
both, both, because it's a directional antenna. It's got high gain to a receive, right?
Interesting. But you have to connect. You connected a coax to your antenna. How would you make it so that the phone can receive it?
Oh, I don't know. I don't know. I'm just saying if you could somehow get some kind of directional antenna, right?
Yeah, yeah. That would do the trick. If yeah, I'd have to figure out which frequency bands to target, which Bell, Rogers, whatever, and then make a
Hassan, this is just somebody who wants to use a standard like cell phone, right? Handheld cell phone.
yes.
Yeah.
Mhm.
So yeah, I mean that what Peter just flashed up on the screen. I've definitely heard of people using them. Can't tell you what the actual results are with them, but has this person looked into those boosters? Do you know?
I think he's tried just about everything, and nothing works. So he needs something out of the box or out of the ordinary. So I was
Okay.
thinking of very long cable and then just an antenna on the top of the hill.
Drew's got his hand up first, and then Charlie afterwards.
Yeah, this has to be a common problem with people at the fringes of coverage. And years ago, I was in the fringes of coverage and I had a brick phone. And the connection for any kind of improved reception just amounted to wrapping a wire around the antenna on that phone. Now, with the current phones, it's a little harder to do, but it occurs to me that if you just put an antenna of roughly the right length at the top of his house. I don't know how high you're talking here. I don't know whether you have any kind of line of sight from his roof versus in his house. Literally LNA and a coax down to a coil in the house. Whether or not that might help. Because it seems as though a lot of these cell phone repeaters, the boosters that they used to put in cars and stuff, unless you could get at the antenna, that was basically all they were. Was just getting a wire nearby.
Oh, I see. Okay.
I mean, it's very unsophisticated.
But if it does the trick, that's fine.
Well, it's a thought. I mean, I don't think it would cost that much to try.
Okay. So just the length, just the length of wire to re-radiate almost. Just pick up the
Yeah,
waves and
basically. I mean,
re-radiate.
if you put an LNA on it, you might even put a little 5-volt LNA on it and just rebroadcast it into the house. I mean, will it work? Probably better on reception. I don't think it'll do much for transmission at all. But
Yeah.
I mean, Usually, it's the reception that suffers.
Okay. Yeah. Okay. I guess it's gonna be.
But Charlie is an expert on these things. I defer him to now that because I think he used to build these things for a living.
Okay.
No, not true, Drew. I didn't build them for a living, but the place I had in Tamworth is poor reception, and I bought one of the boxes that Peter flashed up from Amazon. I think $180 thereabouts. Put it in the basement, and I've had one in the past, maybe 15, 20 years ago, at a different house that I lived at that had poor reception. They work reasonably well. You need to keep because they're a booster, you need to keep the transmitting antenna and the receive antenna as far apart as you can. The module in the house makes a big improvement in a range of about maybe 10 or 15 feet from where it is. So it's not going to give you coverage at the far end of the house, but at the end where you've got the repeating antenna, it will work great. If you get up on the roof and you can see a bar of signal, then you'll have 3 or 4 bars near the antenna inside the house. If you can't get a bar of signal when you're up on the roof, then give up and go home because no amount of amplification is going to help.
So he gets a bar of signal, but I think my suspicion is he's in between two sites of the same frequency or something, and it's just flip-flopping between them. So there's some other effect at work because it's unreliable. I suppose if you have a length of wire of the right thing, I mean, I guess would you put an LC coil at the bottom, or is it not needed? Like the antenna
Yeah,
will self-resonate, right?
well, it will, but you're going to get lots of loss. So if you already got a low signal, it's really not going to help. It helps in the car if if you're inside a Faraday cage basically driving around and you're putting an antenna outside of that cage. That helps. You can live with some loss through there, but trying to do that in the house, I don't think is. Um, if you've got a weak signal to begin with, I don't think you're going to get much stronger. I think you need an amp in there somewhere and a couple $100 to try it. Hey, it's Amazon. If it doesn't work, send it back.
Okay. You see, the problem is he wants to do a software upgrade to his car, and the car won't do an upgrade unless there's a cell phone connection nearby. And so it's like, I mean, I think the car's, it's a BMW. I think it has a satellite connection for updates. I don't think it uses cellular, and it's free, but it's comedy of errors. Like the car won't update unless the cell phone's nearby, and if there's no cell coverage, it won't install the update. So.
Yeah, but man, it's a car. Drive to where there's cell coverage.
Yeah. Right.
Yes, okay. And then the law of unintended consequences. You drive somewhere, you do the software upgrade. What if it doesn't work and your car is bricked? You gotta walk home. So, yeah. All right,
Well,
I'll try
it's
this.
only a BMW, so no great loss.
All right, thanks, guys. I'll try those out. I'll tell them to try this.
Yeah. I think aren't there some phones where you can actually select, what tower you're, like some of these, like maybe a Fairphone or a Plus One or something, where you got a little bit more fine-grained control over the radio inside it.
Guys, if I may,
Yeah,
actually,
Joe,
some
please.
some some of the providers, for example, I believe Fido does this. Uh, there's actually an option in the phone itself that allows you to go VoIP to a point of presence on the internet. So if he's got internet at the house and he's got Wi-Fi in the house and he can get a decent Wi-Fi signal just outside the house, then some of the phones have the option where you actually can tell the phone use the internet to connect back to the network. So it goes partially VoIP back to the carrier and then out.
Recording is on.
At some point, I've been trying to keep an eye on the little record thing, but it was still recording, but I don't know if it was recording. It's, at some point the little red HAL eye turned off at the top of my screen there. So I don't know what's going on. That's kind of disturbing, but the recording was still logged in, but it was not in the main room or something. I don't know. Anyway, okay, so don't know when that exactly cut out, but I think some point during the round table. So anyway, all right. Well, thanks, Frank. Looking forward to that list coming out, and maybe it'll be in time for the for Field Day, which is only about 4 months away. So. All right. So, Michael, you are next on my screen here. How are you? We hear a lot of FT8 in your background there. Now it sounds like a tricorder. I wonder if are you going through a soundboard? So we can't hear you, Michael. All we're hearing is your FT8. Now it's gone, but you're still muted. Unless maybe you've switched over to only communicating in FT8? If so, we can all turn our rigs on and then we can figure out what you're saying, but wouldn't that be interesting? Oh, he's going to try and log back in. Perhaps we should make that a consideration, have a CW only meeting, no voice. See how that goes. Well, maybe we'll wait till Michael comes back in and we'll move on to Cherry. Oh, hang on. Hold that thought, Cherry.
Yeah, I'm here. So can you hear me?
Yeah, we can hear you now.
Okay.
Let Michael finish doing some troubleshooting there. It looks like he's still working on it, perhaps.
Yeah. So, yeah, pretty busy at work, doing some readings like antenna books and so on. So, yeah, nothing really going on my table right now. Yeah, but hoping to get to some kits which I have been sitting around and gathering some dust. So. Yeah, and looking forward to the first of the year somewhere. I've been looking at that data as well, but not really seeing anything other than the one which is happening at Montreal. Yeah, Dave.
What's the next one in the area?
Sorry?
When's the next one in the local area?
Local area, I'm not seeing anything. I'm looking at that RIC website, but I'm not seeing anything actually. There is one website which gives the local Hamfest. I can miss it in the chat, but I'm not really seeing anything happening in the recent. Yeah, I would like to say yes to that question from Dave. Pretty soon, pretty soon it is going to happen. Yeah. So I've not built that yet, but that was something which I was really interested to get to, and kind of even got all the components ordered from DigiKey, and it is sitting in my other table actually. Yeah, unfortunately, I've been busy ever since I got it, and I've been trying to build it as early as possible. But I will get to it so soon. Yeah, so yeah, I'm kind of getting that that from Eric, I think, somehow.
Cherry, you have to look at Peter's face right now. He is not looking very impressed.
I know he is happy about it, but
all the head shaking.
Yeah, sometimes I really feel disappointed because I bought a lot of stuff and it's
I think
sitting
pretty
here.
soon Peter's going to start doing this motion.
So it's gathering dust, and like I'm not really doing anything. Yeah, my
This
wife
buying
has been
stuff
saying
and
that
not
too.
building
Yeah.
stuff is getting out of hand, I think, in this group.
Sorry.
The buying of stuff and not building stuff in this group is getting out of hand.
Kind of true. I want to change that. Yeah, my wife has also been saying that. Like, this is something which I need to change this year for sure. Yeah. Yeah, took all the newer resolutions and I'm working on it. Yeah.
Well, Cherry, it's easy for those that don't have, jobs that, we're all supporting through taxes to say, right?
Yeah, I hope, yeah, this retirement is will happen soon so that I can fully focus on this and do nothing else. That's my dream. Yeah. Thanks. That's all. Yeah. Thank you. Cannot read it. Yeah.
It's a little too fuzzy. All right, Michael. Thank you, Cherry. Michael, are you? No? Oh, what was that? Oh, okay, sorry. I thought I heard you say something there, but no, you're still mute. So, can you blink, CW? No. No, you're not coming through at all. So, yeah.
Did your browser reset some setting or something?
Yeah.
Sometimes it happens.
Yeah. Now he's probably tried all the common things, but all right. Well, if you'd like to put anything pertinent in the chat, you could summarize, I guess. But anyway, okay. Well, we will move on. Kevin, how about yourself? What's going on out in your neck of the woods?
Well, just trying to keep up and recover from all the stuff that's been happening. So I'm getting my shack organized finally, which I said I was going to do this winter. So I'm almost ready, and then I can start building like Cherry and like some other individuals in the group. I've still got a kit left, a QMX kit left over from Dayton last year that I fully intend to have built before Dayton this year. So, because otherwise I'm not going to let myself buy whatever Hands is peddling at Dayton. So anyway, lots of aspirational goals, not too many inspirational goals. How's that? Sorry,
right.
Peter.
Peter is looking less and less pleased with this evening. So, at least I hope the chord progressions are coming along. So
they are actually, and I'm working on that too. That's the other bench that's getting some attention. So anyway, we're bringing guitars to Dayton, are we not?
I think so. Yeah, I think that might just have to happen. We have to show that we did something in the last 12 months, right? So,
and the good thing about that is there's less room to bring stuff back.
All right. Yes. True enough.
So you can say it's a money saving thing. Anyway, on that note, I'm gonna bow out. I have a very early morning, so thanks, guys. It's been good.
All right. Thanks, Kevin.
Thanks, Kevin.
All right. Ciao.
All right. 7:30. Howard, what's new with you?
Haven't been up to too much. Working on the filter board and the relay board, which is part of the filters for the T41 project, and that led to some other diversions. But you'll be happy to know, Eric, that I resurrected that Friends theremin. That was a fun exercise in diagnostic or troubleshooting, I mean, and I have to use the scope for a bit. So I guess I accomplished that.
Hey, is it back in action? Yeah.
What's that?
Is the theremin back in action though? Is it fully operational? Yeah.
So another theremin lives. I can see Peter grinning right now.
Nice. All right. Yeah, we'll have to maybe hijack one of these, SOAREX meetings, make it just all theremin, an all theremin night. So I got a few things to show off too. So yeah.
I think I was just reading Peter's lips. He's muted, but I'm not sure he approved.
Yeah. Yeah, there's a lot of discussion on that T41 Group A. I guess it's the what is it? I can't remember the name of the groups.io, but they have a very, very active. I'd say there's probably a dozen posts a day or something on that.
Yeah, there's
T41
been all
project.
sorts of iterations already of the original design. I'm sticking with the original design, and then see how it works.
Right. But yeah, okay. Like, well, how far along are you in?
Well, once I finish the filter board and test it, then all that's left is the PA board, and then once I do the filter board, actually it'll receive, and then PA board. And looking forward to that to build it and to set it up.
Okay. All right. Thanks very much. And again, the screen has gotten a little rearranged on me, but I would say Drew is next.
Well, good evening.
Evening.
Yeah. So, have not been building a kit. I have a kit to build, and I will build it, so Peter does not curse me out. But in the meantime, what I have been doing instead is working on coils, 3D printed coils. And I saw this plan in Thingiverse and decided to give it a try. It's a fairly straightforward loading coil for what they intend it to be, for about a 12-foot long telescoping antenna, which I don't think I'll bother using. But I did order a smaller one, and I'm thinking on using it as a loading coil for ham sticks. And I'm just going to try and show it to you, because it actually came out not bad. Now I'm going to try to flip the picture around, and I don't know if I can do this. Where's my... Oh, I apologize. Nope. So we'll do that. Can you see it?
Yep.
Yeah. So this is it. It's not very long. You can see by the length. It has adjustable. So you move this up and down and adjust the loading. It's really quite simple. It took about 10 hours to construct. And on that note, the only other thing I've been doing, I have tremendous noise, HF noise at home here. And so I ran across a software package called RM Noise. It's an AI noise filter. And it works very, very nicely. And for those of you who have high levels of noise, 40 meters, 80 meters, unreadable S9 noise, this thing cleaned it right up. And it's free. And it's very simple to set up with just a simple... I thought of you, Hassan. When I got into this thing, I remember your comments about noise. So go ahead.
Yep.
Yeah, just quick question. Is it pre-trained or do you have to train it for your site?
It does pretty well on its own, but you can train it. And it's a simple matter of allowing it to code for as long as you want, say 30 minutes, 60 minutes. And it then incorporates what it has learned into its noise filtering.
Nice, that's clever.
Well, and it's free. I mean, this is the thing, there's nothing to it.
That's really cool. And it works with an SDR or on the audio band?
It works with, it just takes the audio output from your radio and it turns your computer into your radio speaker.
Cool. That's really
So
cool.
it's pretty slick.
Now we just need an AI CW receiver.
Well, it works that way. And interestingly enough, when it's trying to, when you put it on CW, you can see it pause for a second and you don't hear anything. And then all of a sudden you see the dots coming through and you hear it coming through. So it takes a second to figure out whether CW is noise or not.
But does it decode CW?
No. No hope, Eric.
Yeah.
Anyway, so that's what I've got. Is that I'm actually building a taller version of the coil. It's going to take 35 hours to print. So we'll see how that goes.
I'm curious, that ring on the coil that you showed, is that simply support for the, like, where the clip goes, or?
Nope, that is the clip.
Oh, okay. All right.
It
So it's wherever you clamp it down, that makes the connection?
Yep.
Oh, okay.
With a very sophisticated 8/32 stainless steel screw, that screw head rubbing against the stainless steel wire.
Okay, interesting. Do you mind sharing the link in the chat to the Thingiverse?
I'll be delighted to.
Yeah. Okay.
As soon as I find it, I will put it on there.
All right, great.
So that's what I got.
Okay, thanks, Drew. All right, last, I believe, would be Joe. What's going on with you? What are you up to these days?
So I think you guys recall that I was starting to work on one of the QRP Labs kits. So finally, it's built. And at this point, it powers up and the GPS and clock lock on. So this weekend, I plan to take it out in the field and actually do its first transmissions. So that was done late last week, and then earlier this week, another kit came in. I was trying to do an end-fed antenna, so it was one of the ones from HF Kits. So I've got that built as well. So that part of the field testing that I'm going to be doing is taking the antenna out in the field and you know, getting that all like tuned up, cut up to the right size. So those are, so I've got, you know, operational plans for these things probably this weekend. And then other thing I got waiting in the wings. I really liked the GPS board that Hans Summers had done up for the QRP labs. And there's also the clock kit that Hans has. So I actually ordered one of those. So I plan to actually build like the ham shack clock that he's been selling. So I've got those boards and a case waiting in the wings for that. That'll probably get built next week. And then the other thing that I've got going on, not amateur radio related, but will incorporate radio soon enough, because I've been also doing work on the like a review for the Raspberry Pi for next week's or next session's presentation. As Dave, like you mentioned before, one of the reasons why you do the presentations is because you forces you to learn something, right? As you said the last time. And so when I was going through Raspberry Pi and just checking anything new that they had, because I was out of the loop for a while, I didn't know about the Raspberry Pi microcontrollers, the Picos and the Pico Ws. So I thought, oh, I think what I'm going to do, I'm going to order one of these boards because I'd never really played with microcontrollers. So I pulled one of those down, and I've actually managed to program two of them for an actual building application, like actual like commercial building, to check for leaks. So I've actually got two programmed up, and in the building checking for leaks, connected to a service called MQTT. Dave, you wanted to jump in?
Yeah, I wanted to ask. That's interesting, Joe. How do you program it? Do you use like a is it something that comes with the Pi, or you use like an Arduino or a Visual Studio?
So the way that I'll talk more about it in the presentation, but I'll give you the cheat notes. So you can program it with the Arduino software and use that. You just set up the environment, or you can use Visual Studio Code if you want. The Raspberry Pi Foundation, the way they officially support it is actually using a Python interpreter, and you can actually the MicroPython project provides an interpreter that goes onto the board. So you literally pick up the board, press a button, plug it into your computer, release the button, and it shows up as like a USB drive. You drag and drop a UF2 file onto it. Now you've got the interpreter on there. And then you can use VS Code and set that up. Or there's a really simple one called Thonny, which is a open source, and it's on the Raspberry Pi, and I've been using that. So the Raspberry Pi W, which has got both 2.4 gigahertz Wi-Fi and Bluetooth, I've programmed 2 of those up to act as just to check for water leaks at a building that I'm keeping an eye on. And where I'm going with this is I want to incorporate LoRa for these devices to communicate over LoRa. So if I get that going, that'll probably be, Peter, maybe another presentation that I'll do showing something incorporating LoRa, even though it may not be amateur radio, but at least it shows a LoRa and being used.
Hey, it's still all RF, right? So
it's all RF.
Yep.
Yeah.
Oh, you made Peter fall off his chair. Wow. Oh, so he's back. He's back.
I got a lot of catching up to do. Put it that way, boys.
Yeah. All right. Good stuff. Okay. Well, I think that brings me right back to the beginning. All good.
What happened to Eric?
Looks like he's dropped off.
Lousy Wi-Fi in the boondocks.
Oh.
All right. So Jitsi seems to be either choking or my pipe is choking. I'm not sure which, but
it's just you.
Yeah, I mean, the better half is watching a movie upstairs, but still, I don't know if I'm going to blame that or not.
You on dial up there, Eric?
Yeah, really. 300 all the way. Okay. Well, anyway, so I think that is pretty much it. Everybody has had their say. Dave, go ahead.
Muted.
Dave, you're muted.
Yeah.
Thank you. Yeah, Hassan, I just want to mention something about you were talking about ELF. Do you know who Mike Oldfield is? Tubular Bells. You know the soundtrack for The Exorcist. You know that.
Don't remember
that eerie soundtrack? Yeah,
don't remember it.
Eerie. Yeah. Anyway, there's this famous piece of music, like almost classical, and if you listen to it in the background and you decode it, there's actually an ELF Morse code station transmitting, and you can get in the recording studio. They never picked it up, but there's an ELF signal in the soundtrack, and you could hear Morse code, and it's the station identifier. It's pretty cool. There's a video.
So sinister. It's like the devil's frequency.
Yeah, it's like a guy did a video. He actually showed you how he did it. He used a sound card, and he got the music, took it in, filtered it to that really low frequency, and he was able to show you the CW, and he decoded it. It's kind of like the Beatles playing it backwards.
I heard about one guy who built.
We might feel better if you weren't also the guy that irradiated cockroaches as a master's thesis. on a call with a fellow who likes theremins. It's all starting to sound like a 50s sci-fi movie.
Calling Bela Lugosi.
Well, I'm loving it so far. This is like my channel.
Where all the remnants of society, civilization hang out.
And Drew, you've been to those science classes where the professor, the teacher comes in and they've got a rose and they dip it in liquid nitrogen and they smash it.
Yep. Ours was a banana, but yes.
Yeah, we used to do that with like tennis shoes, with like
yeah.
sneakers, and books, because we had just what Joe was saying. We had these vials every morning. We'd have this big dewars of liquid nitrogen, and then at the end of the day, it's going to evaporate. It's because it doesn't keep, right? So we have to do something with it.
Well, as I recall, it was hammering a nail in with a banana.
Yeah, we did shoes. I'm pretty sure we did a book. We didn't do any cockroaches. We didn't freeze them. We irradiated them.
You know what would have been interesting is if you froze them and let them thaw, would they come back?
Oh well, I used to do actually. This is being recorded.
Did I stop the recording? I was about to say, Dave. You've got that look.
Yeah.
So tardigrades you can do. I heard that cockroaches can withstand 200,000 rads of radiation, whereas like a human is like 200.
Yeah, these things would live. They would be going, 10. They'd have the shade and they'd be sitting there tanning,
So Drew, I heard about one guy who built an ELF antenna. I think 60 kilometers of wire, 60,000 turns, like a bunch of tens of kilometers of wire, and he buried it in his backyard, and that was his ELF antenna.
Yeah, there was Hassan. I've been meaning to get this article. I can't find it. I can't remember if it was in a QST or like a ARRL publication or some other place. I don't know where it was, but it was using the Earth as the antenna. So they would take two rods, drive it in the ground, and they would transmit a signal through the Earth.
That's
a very low frequency.
That's telephones.
No.
Later,
it would.
Yeah, they used to do that with telephones.
There was an article, and the guy was measuring how far he could get with that, right?
Yep.
If he's on the Lee line, he'd get a lot more distance.
Good night, Charlie.
Good night, Charlie. It was a good demonstration.
Good night, Charlie. Thank you.
Dave, they're dropping like flies.
Yeah, I know.
I mean, even though you're captivating.
Yeah.
Okay,
anyway, yeah.
You're becoming the stuff of their nightmares.
9:30. No, it's 9:30. I didn't realize. Okay,
those
guys.
are small cockroaches, though.
Anyway, all right. Well, thank you, everybody, for a fun meeting. Next one is 2 weeks from now, Wednesday, the 21st of February. So we'll see you there. I don't actually know what is on the agenda for that one, but it'll be interesting. Giant cockroaches and frozen bananas. So,
I put that link in the chat, Eric.
Yes. I think everybody grabbed that
okay.
Wanted to, so I know I did.
Yeah.
But we can always share it in SOAREX if we need to in the group's IO. So.
Yeah. No, Eric. Next week I'll be doing the presentation on the next session I'll be doing the presentation on Raspberry Pi in general.
Oh, okay. All right. The couple weeks. Yep.
Yeah.
Perfect. Okay. Great. Looking forward to it. Okay.
Right.
Sounds good.
Thank you, guys.
Thank you. Bye.
Thanks, Eric. Cheers.
Bye.